yesterday's lesson, at the very start, I mentioned that there's actually two ways of solving simultaneous equations, or three if you include graphing them. And today we're going to be learning the second one. So this one involves eliminating one of the variables rather than substituting for it. So we'll dive into an example. I'll do an example and then we'll take some notes on it. So, e.g., solve simultaneously. So let's say we've got these two equations, x plus y equals 6 and 3x minus y equals 10. So remember yesterday we called one of them equation 1, one of them equation 2. And we did that as not to get confused with the number 1 and the number 2. We knew we were talking about equations. Now, today what we're going to be doing is looking for which of the variables, x or y, can be eliminated by adding or subtracting the equations from each other. So in this case, what we're going to find is that y has a negative 1 in front of it here and a 1 in front of it in this case, and they're going to cancel each other out if you add them. So let's say equation 1 plus equation 2. We'll add the right hand side first because that's really easy. If we add these two, we get 16. On the left hand side, we've got x plus 3x, and that gets 4x. Positive y plus negative y equals 0. So there's nothing here. So we know that 4x equals 16, and x must be 4 when I divide away that multiplied by 4. And then we proceed exactly how we did before. So sub x equals 4 into, I'm going to do into 1 because it's a simpler equation. 4 plus y equals 6, so y equals 2. Therefore, x equals 4, y equals 2. That's the only time that these two linear equations have the same answer at this point. So what we were on the lookout for was when either x or y has the same coefficient or exactly opposite coefficients. Sometimes that's not the case, and we'll have to do a bit of manipulation to make them the same. You could see if I times this whole equation by 3, I would have a 3x here and a 3x here, which means we can get to eliminating. So let's write some notes and then we shall have a go at another problem. So I'm going to have to type something first before I can move the text box. Alright, let's say we've got to solve simultaneous equations by elimination, you need to look for variables, x or y, that have the same coefficient. If there are none, you can multiply one of the equations so that two variables have the same coefficient. No, wrong screen. Alright. Let's do another example. So let's do another easier one. I'm going to be making this one up, so it might not have a nice answer, it might be a bit more fractiony. So solve simultaneously, let's say 2x minus 3y equals 10, and then let's say 3x plus 3y equals 21. Okay, in this case, you can see there's a 3 here and a 3 here on both these y's. There's also a 3 on the x, but we can't compare this x with this y. We've got to compare this x with this x, and they aren't the same. So I'm going to be focusing on these y's. This one's -3. Oh wait, did I do that last time? Did we have them negative and positive? We did. I'll do them both the same this time. So let's say plus in both of them, because that's an easier change to make. So this time I've got 3y and 3y, and I need to get rid of them. Well, the easier way to get rid of those when they're the same is to minus them, because 3y minus 3y is 0. Also, if it was -3y and then I minused -3y, so they can be the same and negative, that would also equal 0, because that becomes plus 3y, and -3y plus 3y is going to equal 0. So it works if they're both positive or if they're both negative. So what do I need to do? I need to subtract them. Which one am I going to subtract? I might choose this one first because it's got a larger number, and working with positives is nicer. But both will work, and then I'll subtract equation 1. 3x minus 2x is just 1x, or we can write x. Plus 3y minus plus 3y is 0. 21 minus 10 is 11. Well, that was easy. X is 11. Sub x equals 11 into, well, let's go equation 1, it's a bit nicer. 2 times 11 plus 3y equals 10. So 22 plus 3y equals 10. 3y equals -12, because I've taken 22, not divided, taken 22 away from both sides. And then, look at that, we got whole numbers anyway. Divide by 3, divide by 3, y equals -4. Alright, so therefore x equals 11, y equals -4 is our solution. Alright, one more example and then I'll let you guys get into it. So E dot G, solve simultaneously. My writing might get neater because my brother-in-law pointed out to me that my tablet can know if my palm's on it and just ignore it. I've been trying really hard not to touch it. Although looking at it there, it is not in fact neater. Solve simultaneously. Let's go 3x plus y equals -2, and 4x minus 2y equals 8. Now if I compare the x's here, they don't have the same coefficient, but neither do the y's. So I need to do some rearranging first, or some manipulation, to get them to be the same. So what I'm going to do is I'm going to change it so that this has a 2 in front of it by multiplying it by 2. So I'm going to say equation 1, which is why we circle it, times 2, because otherwise it just looks like 1 times 2. Everything gets times by 2. 6x plus 2y equals -2. Remember, we've looked at y. Multiplying both sides does everything. It's because it's kind of like it's got brackets around it, and we're distributive law, distributing it in to every term. Now 6x plus 2y equals -2. Now let's call that, well, that came from equation 1, let's call it 1a, and let's add it because the symbols are opposite. So -2 plus +2 is going to be 0. So 1a plus 2. It's nice to call it 1a and not equation 3, because if you put it back into equation 1 again or something like that, you'll get 0 equals 0 at the end. So always make sure it's going with the opposite number. So 1a plus 2, I shouldn't put out of view because I need them. 1a, so 6x plus 3x gives us 9x. And that's incorrect already. 1a is this one, sorry. 6x plus 4x gives me 10x. Negative y plus 2y cancels out. Negative 2 plus 8 gives me 6. So x equals 3/5 because I divided both sides by 10. So x equals 3, I said 3/5 and then I wrote 3/10. 3/5 into any of the equations. We've got 3 now. Let's do this one, why not? Into 1. 3 times 3/5 minus y equals, sorry, plus y equals negative 2. 9 over 5 plus y equals negative 2. So now I need to take 9/5 away. Use your calculator for that. But 9/5 is almost 2, just 1/5 underneath. So it'll be minus, what's that, 19 over 5. And that's y. And we're done. X equals 3/5. Y equals negative 19 over 5. Everyone happy with that? Make sure on class kick that you are putting your hand up if you need help. I'm going to move away from put your hand up just for me to check. I'll put the answers on the last slide, and you just check if you got it right. If you didn't, then press the ask for help button, and I'll come give you that one-on-one help. It's just taking a while to flick between people, and I have people like B leaving me voice messages asking me to help her for 30 seconds straight, while I'm just checking someone who's got it all right. So we just moved to that. Only ask for help if you got it wrong when you check with the answer. And then you're right to go on with the textbook work. Thanks.